Hello, everyone, and welcome. We are Team Fake Computer, and today I'm going to show you a little bit of code that we've written, and then we're going to demo our fake computer. So what you're looking at here is a function to draw to our RGB matrix panel. We've written this library entirely from scratch, and I want to just walk you through a little bit of the basics on how this works so you can have a better understanding of what's actually going on underneath the hood, seeing as this is an engineering class. So the way that this works is when we want to write to the panel, we essentially write two rows at once. So we start from the top row and the middle row, which would happen to be row 0 and row 15. And then we go down to row 1 and row 16, row 2 and row 17, all the way down to row 15 and rows 33. So we're writing two rows at once, and each row is 64 bits wide. So essentially, we have to clock in 64 bits for red, green, and blue for both of the rows in order to fully populate those rows. And to do that, we just have these handy matrices R, G, and B, which store essentially the board red, green, and blue pixels. And we use this logic in the if-else statement to essentially clock that in. Now, each time that we set a pin to high or low in order to indicate data being sent to a particular pixel, we switch the clock on and off, and that allows the shift register to advance one cycle, and we can thereby input the next pixel's worth of data. Once we've input all 64 pixels worth of data, we can enable and disable the latch and set the appropriate rows that we're writing to, and that will allow us to update our board. Now, another really interesting thing is we've written all sorts of really cool functions to get this to work, and this library is pretty versatile. We've also created a draw character and draw string function, which essentially pulls from this font library that we found and allows us to draw individual characters to the board, something that is non-trivial and is very technically challenging to get working. Something else that's really challenging to get working was actually drawing diagonal lines, and so we've used Bresenham's algorithm to do this efficiently. This is one of the more efficient ways to actually draw a diagonal line. We've adapted it to allow both positive and negative slope diagonal lines, where you essentially input your top left point and your right point, whether it's below or above your rightmost point on the line, and then the color using these three booleans indicating whether or not to write up the red, green, and blue. And this algorithm is implemented to do exactly that. And then we can go over to our main function, and we have various things going on. Essentially, we're using ADC, we're using timers, we're using interrupts, and this allows us to interact with our joystick and put everything all together and show you the demo that I'm about to show you.
Thank you, Max. Hey everyone, this is Benjamin. Here I am with the joystick module controlling Fake Computer. Right now I'm in cursor mode, meaning I'm able to move my cursor around the screen without drawing anything. That changes once I press the button. That'll lead me into a drawing mode. Right now I'm drawing in red. I'm able to go up, down, left, and right, as well as diagonally. I'm able to cycle through different colors as well. We provided colors for the color green. Very nice color, it's my favorite color. Yellow. Blue. Magenta. Turquoise. And white. After that, it cycles back to the cursor, which also acts as an eraser. Another interesting capability we had with this project was the ability to write text. And this is done by timing the amount of seconds that happens when holding down the button. So I'm going to change it to blue really quickly, hold it down for a few longer seconds than I would for changing color, and then select my letter. This is my interpretation of the state of California. When you're all done, you can hold down the button for longer than all those periods, and that will then delete. Thank you all for watching. If you have any questions, be sure to email us.